In this video, we are going to show you how to navigate through some important specifications on a typical 3-wire inductive proximity sensor datasheet. We're going to look at 3-wire proximity sensor datasheets from two different vendors and discuss the specifications which are common. Before we dive into the proximity sensor datasheets, we're going to quickly review what a 3-wire inductive proximity sensor is, discuss the different output types, and look at the schematic symbol of a 3-wire inductive proximity sensor. A 3-wire inductive proximity sensor is an electronic device that can detect ferrous, or Fe, targets without any physical contact. When it detects that target, it operates an internal electronic switch. Because the sensor is an electronic device, it requires a DC power source. Proximity sensors are being used in industry today to replace devices such as mechanical limit switches. There are two different types of 3-wire inductive proximity sensors, NPN and PNP. The symbol that best illustrates the proximity sensor was developed by the International Electrotechnical Commission, or IEC. There are a number of figures inside the symbol representing the 3-wire inductive proximity sensor. The diamond indicates it is a proximity sensor. Fe indicates that it is an inductive sensor. The transistor indicates it is an NPN output type. The normally open switch indicates that the internal electronic switch closes when the proximity sensor detects a target. Okay, let's look at data sheets of two typical 3-wire inductive proximity sensors. You can find the links to these data sheets in the description. Let's discuss the output type specification. The output type can be PNP or NPN, which determines how the load is connected to the sensor. Although they can both look identical physically, they are not interchangeable. Operating current, or switching capacity, in milliamp is another specification to discuss. Unlike a mechanical limit switch or other similar devices, a proximity sensor can only carry a low amount of current before being damaged. For these sensors, the maximum current allowed is 200 milliamps. An important specification is operating voltage, or supply voltage limits. As discussed earlier, the 3-wire proximity sensor is an electronic device and requires a DC power supply. Sensor data sheets will always provide a range of power supply voltages in which the sensor will operate as designed. Let's look at the switching function or discrete output function specification. Just like any switch, proximity sensors can have normally open, NO, or normally closed, NC, contacts. This datasheet specification indicates the state of the switch before it is activated. Another important specification is the voltage drop or maximum voltage drop. Most of us assume that a closed switch will have 0 volts dropped across it when it is closed. In most cases, this is true. Unfortunately, in the world of electronic proximity sensors, this is not the case. This datasheet specification indicates how much voltage could be dropped across the proximity switch when it is closed. This may or may not be an issue, but be aware that a voltage loss will occur. Another specification to consider is switching frequency. Every time the target gets close to the proximity sensor, the internal switch operates and creates a voltage pulse. Is it possible to use the proximity sensor to measure speed? It is not intended for this purpose, but perhaps at low speeds. Each time a gear tooth passes the sensor, a voltage pulse is created. The speed, or RPM, of the geared wheel is determined by converting the pulse train frequency. A proximity sensor has a switching frequency specification, which limits its use to measure speed. There are sensors designed for speed measurement that operate exactly as proximity sensors. An important specification is the rated operating distance, or nominal sensing distance. Simply stated, it is the distance under ideal conditions that the sensor can detect the target and successfully operate its internal switch. Keep in mind that this specification does not take into account external conditions, such as voltage supply and temperature. Let's talk about the specification called Switching State Indicator, or Status LED. Almost every vendor will have an LED indicator of some kind as part of the physical body of the proximity sensor. The purpose of the LED is to indicate when the proximity sensor is activated. Be careful because the LED will come on even if the load is connected incorrectly. If you want to learn more, you might want to review our video called How to Wire Discrete DC Sensors to PLC. You can find the link to this video in the description. In review, vendors use slightly different names for proximity sensor specifications on datasheets. Fortunately, similarities assist us in determining the important values we need to use and troubleshoot them correctly. Newcomers to RealPARS have free access to one of our online courses. You can take advantage of this offer by downloading the RealPARS app and selecting the first lesson of the PLC hardware course. Just like this video, the lessons are all high quality and also very easy to follow. Also, for a low monthly fee, you'll get full access to an exclusive library of courses on PLC programming and industrial automation topics, as well as new fresh out of the oven videos each and every week. These courses are all member exclusive and are not shared anywhere else on the internet.